Hi everyone, this is Srikanth as Assistant Professor of EEE Department. In this session, I am going to cover the bipolar junction transistors and their characteristics. A bipolar junction transistor is a three-terminal semiconductor device which the operation depends on the interaction of both majority and minority carriers, and hence the name is given as bipolar because of majority and minority carriers in both the junctions. The conduction of the device is going to take place, so because of that it is called as bipolar junction transistor. Tri is nothing but 3. So 3 layers will be there in this transistor, that is either NPN or PNP layers. So based on the layers which we have used, their junctions are going to be different. So it is used in amplifier and oscillator circuits and as a switch in digital circuits. And these transistors are going to be used in the amplifier and oscillator circuits, and also it also work as a switch, as like how a diode worked as a switch. In the same way, transistor also will work as a switch in the digital circuits. Here transistor means transfer resistance. Transfer resistor, that is, signals are transferred from low resistance to high resistance circuit. In most transistors, it contains 3 terminals, that is emitter, base, collector. So whatever the 3 layers in the transistors are called emitter, base, collector. Here emitter is heavily doped and its job is to emit or inject electrons into the base. Emitter is a heavily doped layer. Its job is to emit or inject electrons into the base. Whatever the emitter electrons will be moving towards the base. And base is lightly doped, very thin, and it passes most of the emitter injected electrons onto the collector. Emitter is lightly doped and very thin, and it is just like a mediator between the 2 layers. So whatever the electrons which we are getting from the emitter layer, that will be passed to the collector. So the base will work as a mediator between the emitter and collector. And the doping level of collector is intermediate between the heavy doping of emitter and the light doping of the base. Here, for the collector, the doping level will be in between the emitter as well as in between the base. So base is lightly doped and emitter is heavily doped and collector is lightly doped. A BJT is a transistor that uses both electron and hole charge carriers. Here BJT name itself we got that, where the charge carriers are both electrons and holes. It comes in 2 main types. The BJT is going to have 2 main types. One is NPN, negative, positive, negative, and PNP, positive, negative, positive. And the basic structure of BJT includes 3 semiconductor regions: the emitter, base and collector. First we'll go with the NPN transistor. In NPN transistor, when we take emitter is of N type, and this region is heavily doped with electrons, that is negatively charged carriers, and base is the P type. This region is lightly doped with holes, positively charged carriers. Now when we go with collector, again it is of N type, and this region is moderately doped with electrons. The next one is a PNP transistor. In the PNP transistor, emitter will be P type. This region is heavily doped with holes. P type means the doping is also with holes. And base region N type, this region is lightly doped with electrons. And collector, this region is moderately doped with holes. The collector is so named because it collects electrons from base. It collects electrons from the base. The collector is the largest of these three regions. The collector is going to have, the area will be the largest of all these three regions. The transistor has mainly two junctions. Three layers means we are going to have two junctions. One is between emitter and the base, and between the base and the collector, Here this is the two junctions representation with the help of diode. This is a PN junction diode which is connected in a forward direction, and these two diodes are connected in the opposite directions, because when we take the NPN or PNP, if we take the PNP is PN junction in the first, so this is the PN junction diode, and this is PN junction diode in the reverse direction. P is from this direction, so the diode is replaced here, anode is connected in this direction. So these two diodes are connected in the opposite directions. Whatever the joining point is nothing but the base, and the starting point is emitter, and the ending point is collector. And if you go with NPN transistor, these two will be diodes, direction will be reverse. Both the anodes of the two diodes are connected, and cathodes will be open to the circuit. And this is the way how we are going to have the PNP and NPN transistors. This is emitter, base, collector. This is the emitter base junction. This is the base to collector junction. Two junctions we are going to have in the transistors, and three layers which we are going to have in the transistors. And this is the circuit symbol of transistors. That is, here this is the collector, and this is the base, this is the emitter, and here it shows in NPN transistor the current direction is towards the emitter. This shows that this is a NPN transistor. If we are having circuit symbol with current direction from the emitter, then that is a PNP transistor. The modes of operation. Here we are going to have different modes of operation of emitter base junction and collector based junction. So when emitter based junction is reverse bias and collector based junction is reverse bias, the circuit will be in whatever the transistor will be in cutoff mode of operation. If emitter based junction is forward bias and collector based junction is forward bias, then it goes into saturation. And if emitter based junction is forward bias and collector based junction is reverse bias, then it will go in a active mode of operation. And if emitter based junction is reverse bias and collector based junction is forward bias, then it is a reverse active mode of operation. This is the way how the operation in the transistor is going to takes place. So here when we are having NPN transistor, we are going to connect the emitter base junction as forward bias and base to collector junction as a reverse bias. Base to collector junction as reverse bias, because we need to get the active mode of operation. Emitter base junction is forward bias and collector base junction is a reverse bias. In that condition, the mode of operation is active. So here for n type, to make the n type as this NP junction as forward bias, we are going to give a negative terminal to the n type and positive terminal to the p type. Positive terminal to the p type, so that this junction will get forward bias. This junction will get forward bias. Once this junction is forward bias, the whatever the electrons, which is this negative is connected to the n type and emitter is highly doped. When the emitter is highly doped, the negative is connected to the electrons. So electrons and negative will be repel each other. So the electrons will move from the n layer to p layer. That is nothing but emitter to base junction. Emitter to base junction. So the current conduction will take place from emitter to base junction. And then after here, the collector current is is connected, positive is connected to the n type and negative is connected to the p type. So here this negative, the in the p type, whatever the electrons which we are going to get, these electrons will move towards the n collector. So because this negative is going to repel the electrons in the p layer, whatever the electrons will be moved towards the n type. And here the positive connection of voltage, positive voltage is connected to n type. That is nothing but positive is connected to electrons. Always positive will attracts the electrons. When the positive attracts the electrons will move towards the collector. That is from the emitter to base and base to collector. The conduction will takes place in this direction. Here the base to emitter junction is connected in the forward bias condition by a supply voltage of VE, and the collector base junction is connected in the reverse bias condition by supply voltage as VCC. In forward bias condition, the negative terminal of supply voltage source is connected to n-type semiconductor as we have seen. And similarly, in a reverse bias condition, the positive terminal of supply voltage is connected to the n-type semiconductor, that is collector. Here the depletion region of emitter base junction is thin as compared to the depletion region of collector base junction. Note that depletion region is a region where no mobile charge carriers are present, and it behaves like a barrier that opposes the flow of current. Here depletion region is nothing but whatever the junction where we are going to have no charge carriers are present, and it behaves like a the barrier between the two layers. And in n-type emitter, the majority charge carriers is the electrons, and therefore electrons starts flowing from n-type emitter to p-type base, and because of electrons the current will start flowing in the emitter base junction, and this current is known as emitter current. Whatever the current which is flowing from emitter to base, that current is called emitter current, and these electrons will move further to the base, and the base is a p-type semiconductor, therefore it has holes. Here the base region is lightly doped, so few holes are recombined with the electrons, and hence most of the electrons will pass through the base region, and few of them will recombine with the holes. So because of the recombination, the current will flow through the circuit, and this current is known as base current because of a recombination of holes and electrons, and the current will flow through the circuit, and this current is known as base current. And the base current is very small as compared with the emitter current. Typically it is of 2 to 5% of total emitter current. So if we take 100 amperes of emitter current, we are going to have 2 amp 2 amperes to 5 amperes base current will be there in the transistors. Here most of the electrons will pass the depletion region of a collector base junction and pass through the collector region, and the current flowing by the remaining electrons is known as collector current. So whatever the electrons which are moving towards the collector from the base region, those electrons will create a current. That current is called a collector current, and this collector current is large as compared to the base current. Here this is the basic circuit diagram for the NPN transistor. Here the base current and load resistance are connected in order to limit the base current, and load is the where we are going to take the output. And here is the VB, and here we can write this is P type, N type, and N type. This PN junction should be emitter to base junction should be forward bias. That's why we are giving the base voltage as VB, and this positive is connected to P type and negative is connected to N type. And here the collector to emitter junction should be reverse bias. So this is VC is connected, and this VC is connected to N, that is nothing but positive is connected to N is nothing but that is the reverse bias. The voltage sources are connected to the NPN transistor as shown in the above figure. The collector current is connected with the positive terminal of supply voltage VCC with the load resistance RL, where across the collector we are going to take the load. Whatever the output we are going to take, that is from the collector we are going to take. The load resistance also used to reduce the maximum current flowing through the device, and the base terminal is connected to the positive terminal of the base supply voltage with base resistance, and the base resistance is used to limit the maximum base current. And here, when the transistor is switched on, a large current flows through the device between the collector and emitter terminals, but for the small amount of base current must flowing into the base terminal of the transistor. By KCL, the emitter current is the addition of base current and collector current. So IE is equals to IB plus IC. Now let us take the different modes of operation. So the first one is the transistor operates on different modes or regions, depends on the biasing of junctions. It has three modes of operation. One is cutoff mode, second one is saturation mode, third one is active mode. First one, cutoff mode. In cutoff mode, both junctions are reverse bias. In this mode, the transistor behaves like a open circuit and it will not allow the current to flow through the device. When both are reverse bias, there is no conduction of current, there is no path for the current to flow, or there is no electron movement from one junction to another junction. Hence, the diode will act like a open circuit. And the next one is saturation mode. In the saturation mode, both the junctions are connected in forward bias. The transistor behave like a closed circuit. The current flow from collector to emitter, and when the base to emitter voltage is high. So in this mode, both the junctions are forward bias. When both the junctions are forward bias, current flow will take place from collector to emitter when the base to emitter voltage is high. So always current should flow from emitter to collector. Emitter, base and collector. And here the current is flowing from collector to emitter when the base emitter voltage is high. And the next one is active mode. In this mode of transistor, base to emitter junction is forward bias and collector base junction is a reverse bias. This mode, the transistor operates as a current amplifier. And these are the characteristics corresponding to the collector current and collector to emitter voltage. So the current flows between the emitter and collector, and the amount of current are proportional to the base current. Here IC is the collector current which is flowing, and this is the VCE. When we increase the VCE value, once the conduction takes place, up to the conduction takes place, the current will increase. Once the conduction takes place, the current value will be constant. In the same way, when we take the different values of collector current, we are going to have the voltage value. Even though you increase the voltage value, whatever the IC value you consider, that will be of saturation type. So here in this region, this region is called the saturation region because the voltage will be nearly constant. And here this is the active region where the transistor is going to work, and this is the cutoff region. In this region no conduction will take place in the transistor. The next one is the operation of PNP transistor. The operation of PNP transistor will be, here we are going to have holes, electrons, and again holes as the majority carriers. So here emitter base junction should be forward bias. So emitter is connected with a positive so that holes will repel from the p-type layer. So the holes will start moving towards the junction, and this depletion layer, once the holes are moving towards the junction, the depletion layer between the p and n junction is going to be removed, and the conduction will take place from p to n type. So when the conduction is taking place, the holes are there in the n type, and these holes will recombine with the electrons available in the base junction, base layer. And after recombining, because base layer is lightly doped, after recombining most of the holes will be free because base is a lightly doped layer. So these holes will move towards the collector junction. So once these holes will move towards the collector junction, and the conduction will takes place from emitter to collector, because here collector is connected to the reverse bias, that is holes are connected to the negative supply. So the holes will be attracted to the negative voltage. Here a PNP transistor is a bipolar junction transistor constructed by sandwiching an n-type semiconductor between the two p-type semiconductors. And a PNP transistor has three terminals: a collector, emitter, and base. The PNP transistor behaves like a two PN junction diodes connected back to back. These back to back PN junction diodes are known as the collector base junction and the emitter base to emitter junction. And this is the symbol we have seen, that is PNP transistor with the diode, and this is the collector where we can collect the all the current from the both emitter and base layer. The construction of PNP transistor is similar to the NPN transistor. In an NPN transistor, one p-type semiconductor is sandwiched by two p-type semiconductors. Sorry, here two n-type semiconductors. And in PNP transistor, one n-type semiconductor sandwiched by two p-type semiconductors. In p-type semiconductors, the majority charge carriers are holes. Therefore, in the PNP transistor, the formation of current is due to the movement of holes. Just now how we have seen. In the PNP transistor, the current conduction will take place because of the holes. The middle layer is called base terminal. The left P layer works as emitter terminal and the right P layer will work as collector terminal. The emitter and collector layers are heavily doped compared to the base layer. Emitter and collector are heavily doped, whereas emitter is heavily doped, collector is moderately doped, but these two are heavily doped than the base layer. Therefore, the depletion region at the both junctions is more penetrate towards the base layer. So the area of emitter and collector layer is more compared to the base layer. Area is also more when compared with the base layer. In n-type semiconductors, a large number of free electrons are available, but the width of the middle layer is very small and lightly doped. So significantly less free electrons are present in the base region. The symbol of PNP transistor is as shown in the below figure. The arrowhead shows that the current will flow through emitter to collector. Arrowhead shows that current will flow through emitter to collector. And this is the PNP transistor. The current flow will be from emitter to collector. This is the symbol. And this is the way we are going to have the holes and electrons in the PNP transistor. Here these are the holes and these are the electrons, and these electrons will recombine with the holes of emitter and remaining holes will move towards the common base junction. Due to this type of bias, the depletion region at the emitter base junction is narrow because it is connected in forward bias. In emitter base junction, the depletion region is forward bias. So because of that, the depletion layer is less narrow. And when the collector base junction is reverse bias, and hence the depletion region at the collector base junction is wide. And emitter base junction is in forward bias. Therefore, a very large number of holes from emitter cross the depletion region and enter the base. Simultaneously, a very few electrons enter in emitter from the base and recombine with the holes. And here the loss of holes in the emitter is equals to the number of electrons present in the base layer. So how many holes are lost is due to the number of electrons present in the base layer, because all the electron hole pairs are created in the base layer because of holes are moved towards the n type. So but the number of electrons in the base layer is very small, so because it is very lightly doped and thin region, therefore almost all holes, therefore because very less electrons are there, so electron hole pairs are created, but which are of very less, and whatever the remaining holes are, that is nothing but almost all the holes will move towards the emitter base junction, and this current, sorry, base to emitter junction. So because of the movement of holes, the current will flow through the emitter base junction, and this current is known as emitter current, and the holes are majority carriers to flow the emitter current. and the remaining holes which do not recombine with electrons in base, that holes will further travel to the collector. The collector current flows through the collector base region due to holes. This is the circuit how we are going to connect for PNP transistor, and the base resistance is connected in order to limit the base current, and load resistance also, which will limit the collector current, and also it works as a load where we can take the output from this circuit. Now if we compare the circuit of PNP and NPN transistor, here the polarity and direction of current are reversed. If a PNP transistor is connected with voltage source, the base current will flow through the transistor. The small amount of base current which controls the large amount of current through emitter to collector, provided the base voltage is more negative than the emitter voltage. Here, because of base current flows, because of that base current only, the conduction is taking place from emitter to collector. So once if we give a small amount of base current, the conduction will take place in the transistor. That's why these transistors are also called as current controlled device. If the base voltage is not more negative than the emitter voltage, the current cannot flow through the device. So it is necessary to give a voltage source in the reverse bias more than 0.7 volts. It is definitely we have to maintain the reverse bias voltage is more than the cut-in voltage. 0.7 volts is nothing but that is more than the cut-in voltage of the diode or two layers which we are connecting. The two resistors RL and RB connected in the circuit to limit the maximum amount of current through the transistor. And here if we apply Kirchhoff's current law, the emitter current is a summation of the base current and collector current. IE is equals to IB plus IC, and IC is equals to IE minus IB. Now the major key characteristics of the transistor are current amplification. The primary function of a BJT is to amplify the current. A small current at the emitter base junction, that is base to emitter junction, we are going to give a small current that controls the much larger current flowing in the collector and emitter. And BJT has three terminals: emitter, base and collector. The current flowing between the collector and emitter is controlled by the current flowing into the base. And the modes of operation we have already discussed. One is active mode. In this mode, the transistor is operating as an amplifier. The current flows from collector to the emitter and the transistor is in the on state. In cutoff mode, when there is no base current, the transistor is in the cutoff mode and there is no current flow from collector to the emitter. The next one is the saturation mode. When the base current is sufficient to allow maximum current flow from the collector to the emitter, the transistor is in the saturation mode. And next is the transistor action. In an NPN transistor, electrons flow from emitter to the collector. In a PNP transistors, holes flow from emitter to the collector. And these are the applications of transistors. Amplification. BJTs are commonly used in amplifiers in electronic circuits, providing voltage or current amplification. And the next one is the switching. These transistors can also be used as a electronic switch, as like the diode. And oscillators, they can be part of oscillators generating periodic waveforms. And next one is the signal modulation. In communication systems, BJTs are used in various modulation and demodulation processes. In this session, we have discussed the basic introduction to the bipolar junction transistors and the operation of NPN and PNP transistors and their applications. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.